So, rectangular coordinates, that's going to be the topic of today's lecture. And even though that you might not be familiar with that phrase, rectangular coordinates, you guys probably have used Google Maps, or if you throw back all the way to the days when you were in a social studies class, you learned about latitude and longitude, right? Coordinates are how we map locations in space. But when we're talking about mathematics, when we're talking about algebra, we want to be able to basically describe the world around us. So it's not necessarily just going to be space, but it could be the relationship between two variables. Okay. So we really want to get into this thing and understand the rectangular coordinate system. How many of you guys are familiar with or have heard of the x-axis and the y-axis?
Yes.
Okay.
Yes.
So it shouldn't be alien. So some of this might be familiar stuff, but we want to make sure that we're getting this down pat and understanding, what these words mean. There's going to be some vocabulary here, and you're going to need to know these definitions because they're going to help you solve problems. And not every problem is going to be spoon-fed to you. It's not going to be obvious exactly what to do, but you need to fall back on these definitions for these concepts, okay? So first, I want to talk about related quantities. And so actually, without looking at this PowerPoint slide, I'm going to switch over to my document camera real quick. And let's think about something. How many of you have gotten gas within the last week and just put gas in your car, right? That's something that we traditionally do. You have to, regardless of what gas costs. You drive by the QT, for instance, and you know that on the sign it says 1 gallon of gas, right? Costs how much? Like, can anybody tell me like what was the most recent gas price that they saw?
2.91.
2.91. Let's go with that, right? So you might not think about this, but when you drive by that gas station, what that sign is really saying is that it's $2.91 for 1 gallon of gas. So we're really talking about two different things. We're talking about gallons of gas, and we're talking about money, right? Or the cost for 1 gallon. But those are two different concepts, they're two different objects. So let's say, for instance, I had a little tank of gasoline, a little container, and I needed to fill up my lawnmower with some gas. And maybe my lawnmower is a small little engine and it takes 2 gallons of gasoline. Can anybody tell me how much that would cost me if we have a 291 rate? How much would it cost to buy 2 gallons? Or how would we figure it out, even if you're not sure? What do you think we need to do to calculate that?
291 times 2.
Yeah, that's exactly right. We're going to do 291, which was the rate for 1 gallon, and then we're going to multiply by the number of gallons that we have here, and that will give us our final price. So we'll go 291 in the calculator times 2, and we get 582. Okay. Now, in this example, we're not taking into consideration sales tax. So we have just a really rough estimation of how much it's going to cost for 2 gallons. Can anybody tell me how much it would cost to buy 3 gallons of gas? Or what's the process that we would do to find how much that costs?
291 times 3
That's
gives
exactly right.
873.
You said it was 873?
Yeah.
Okay, I'm going to trust you on that because I am too lazy to put that in the calculator myself. Okay. Okay. So in general, do we have like a pattern? Let's say that I wanted to skip 4 gallons and 5 gallons and 6 gallons, and let's get straight to like a 10-gallon tank. What would I need to do there?
291 times 10.
Okay, do you guys see how painfully obvious this is? Right, and then that one I can do. The trick when you're multiplying by tens is that it just moves the decimal over one place. So this should be 29.10. Okay. So if I said we have X number of gallons that we want to purchase, can you tell me, even though we don't know what that number is, right? That's just a placeholder for a number. Can you tell me how I would calculate how much X number of gallons would cost? I think I heard something, but it was a little muffled. Can you repeat that?
Would you do X times?
298x.
Oh,
No, a little bit louder?
291x.
Yeah, it's 291 times X or just 291X,
Hmm.
right? Because when you put a coefficient next to a variable, that implies that you're multiplying, right? So
Correct.
this is the relationship between gas and the price that you end up paying at the pump. You just take the gallon rate and multiply it by X number of gallons. Okay. And so what mathematicians will usually do with this relationship is that they will write it out as follows. They'll say, let the gas be represented by the variable X, right? Because that's the thing that you get to choose when you go to the gas station, right? You are choosing how much gas to get. And I know that it's a little bit of a weird scenario because like gas is gas and you have to buy it to get to work and live your life. So regardless of how much money it costs, you just pay it. But if you were like, let's say this was the 90s and you didn't have a credit card or debit card and you had to pay with cash, usually you would budget things, right? And you would say like, oh, I could only afford X amount of gallons, okay? So you choose the number of gallons here, and then that determines what becomes this price, which we can call the Y variable, right? So mathematicians will say this relationship can be written as y is equal to 291x. And this is called a linear equation in two variables. And the two variables are x and y, where x represents gas, the number of gallons, and y represents the total cost. Okay. Now, again, we're being extremely extra here because like you could do this with anything in your life. Like if my stepson was playing football and I was responsible for getting like the Capri Suns at a particular game or an event, then I would have to go to the store and say, well, how much does a box of Capri Suns cost, right? How much does one box cost? And then how many boxes do I need? And then I would just multiply the price of one box times the number of boxes. And that's a simple linear equation. Um, and so whenever you read something about this kind of stuff in math textbooks, they word it or phrase it in terms of related quantities. Okay. That things in life tend to be connected or have an influence on each other. And so some examples of these related quantities that might affect each other is like if I went to Planet Fitness, right? The amount of money I would spend in a year at Planet Fitness depends on how many months I keep my membership, right? So the number of months that you maintain your gym membership affects the total cost over the however many months you end up having that gym membership. Okay. Another scenario would be like during a particular season of the year, I believe it's in fall, you see a lot of butterflies flying on the highway. And I'm sure that as all of us are driving, we're slamming into these things and killing dozens, if not hundreds and thousands of butterflies. But regardless of that sort of morbid scenario, the number of cars that are on the road affects the mortality rate of butterflies, right? It affects their population. So you can imagine that as you have a higher number of cars on the road, you probably have a higher death rate of the butterflies. Or said another way, you have a lower population because you're killing them as you're running into the butterflies and they're splattering on your windshield, right? All I'm trying to say here is that we are going to learn about how an x variable that you plug into an equation or plug into a function will generate another value, and we need to keep track of both of those values. Okay, so we're gonna take a look at this butterfly scenario in a little bit more detail because I'm a biology major. I studied biology and I like to inject that into my math classes a little bit. So you might not be aware, but the butterflies that fly through Texas in, I believe, in the fall, um, are called American snout butterflies. And researchers in 1921, they did a recording and measured and counted, and they, based on their research, they estimated that about 25 million of these snout butterflies migrate from the area from South San Marcos to the Rio Grande Valley per minute. So in any given minute, there's about 25 million butterflies that fly in that area. Okay. So using that relationship, I want you to think about this. Okay, we know how many butterflies fly through the area in 1 minute. Can you guys tell me how many butterflies you expect to fly through that area in 10 minutes? Or how would you go about figuring that out?
25 minutes times 10 or 25 million times 10.
25 million times 10. That's exactly right. Right? It's exactly the same as that gas scenario, right? So we can think about writing an equation after we establish a pattern, right? So first we have to define our variables. We have to say, let x be the number of minutes that pass. So x represents time, okay? And let y represent the number of butterflies that migrate through that area. And since we know that 25 million fly through that area per minute, per 1 minute, then we can just say, oh, for 10 minutes, just multiply 25 million times 10, right? If you look at this equation that I have written down here, y equals 25, that 25 is really 25 million. I just left off the million part, but times the number of minutes. So we can say, oh, if I take 25 times 10, that's 250 million butterflies that have flown through the area. In 30 minutes, all I have to do is 25 million times 30, and I get 750 million butterflies that have flown through that area. And then in an hour or 60 minutes, all I have to do is 25 times 60, and that equals 1,500 million butterflies that have flown through that area. Okay, does that make sense? Or is
Yes.
that the
Yes.
craziest thing you guys have ever heard?
Yes, it makes sense.
Okay, good. All right. So, like I said, we want to keep track of these two variables at the same time. But if any of you guys have any experience working with data, like if you've ever worked at a hospital and you have to look at a patient data, if you look at a spreadsheet, there's a bunch of numbers that you have to keep track of. And whenever you're looking at just a bunch of numbers, it's hard to make sense if there are any patterns. Okay? And so we are going to manipulate numbers and we have to keep track of our x values and our y values. And the way we're going to visualize if there's a pattern or a relationship between those two variables is by graphing them. And so that's why we have to introduce the Cartesian coordinate system, okay, to keep track of those two variables and how they're related to each other, okay? So again, the Cartesian coordinate system, if you've never heard the word Cartesian, um, it's just a grid system like latitude and longitude on a map that will help us locate different points in that space on the map. Okay. It's called the Cartesian coordinate system because it's named after René Descartes, who is a French philosopher from God knows when, the 1800s, the 1700s. But he also happened to be a big contributor to what we know about geometry and algebra. Okay. So you can call it the Cartesian coordinate system, the rectangular coordinate system, or you could just call it the graphing system. That's fine with me. Okay. But what you need to understand is that that coordinate system is built by taking a number line that we lay horizontally. This is your standard number line. You could think about like 0 being in the middle of that number line. As I count to the right, you have 1, 2, 3, 4, and so on. And then we continue all the way to positive infinity. Those are the positive numbers. And then on the left, we have -1, -2, -3, and so on and so forth, all the way until we count to negative infinity on the left. That's not the craziest thing that you guys should have ever heard because like this is really like elementary / middle school stuff, right? But what gets a little bit trickier is when we say, okay, well, that one number line is just one dimension of information. It will record everything we know about the x values. But now we're going to take, and let me erase some of this stuff. We're going to take another number line and put it perpendicular in the middle of that first number line, okay? And we're going to call that the y-axis, and that's going to keep track of any of the y values that we have for any of these equations that we're going to work with, okay? And similar to the x-axis, we can start with 0 in the middle of the y-axis. That's going to be a y value of 0. As we count up, naturally, we should count in the positive direction. So we have 1, 2, 3, 4, 5, 6, so on, all the way until we go all the way up to positive infinity. And then if we were to count down, we would go down to -1, -2, -3, -4, and so on until we get to negative infinity. So we need to keep track of two directions now. The x direction is left and right. The y direction is up and down. Okay? So if I were to ask you guys, can anybody tell me what is the coordinates? What's the x coordinate for this point that is floating on this graph now? What's the x coordinate?
3.
Z- 0, 0, 3.
Not 0, 3. Right? If we just want the x coordinate, we just need the x value. So we're just going to start in the middle of the graph. Sometimes you might have heard this point here called the origin, but we're just going to count 1, 2, 3. And so that's going to be our x value of 3. And our point is hovering right above that.
So 3, 2.
So yeah, I think you're getting ahead of us a little bit, but here we go. We have an x value of 3. We have a y value of 2, right? So any point or ordered pair has to be described by two numbers. If you tell me that point is at 3, I'm going to be like, 3 what? Because if we were doing like a covert operation in the military and you were to give me, you needed to give me the coordinates latitude and longitude, but you only gave me latitude, I would have no idea what village to bomb, okay? I might end up bombing the wrong village. You have to give me both the x value and the y value so that we can bomb the right village, okay? Jokes aside, it's very important that you keep track of both of those coordinates for every single point, okay? And 3, 2 is how we're going to describe that. And I have in the next slide a little bit of a quiz just to make sure that we understand how to correctly describe these points. But as I mentioned before, this point smack dab in the middle at the intersection of the x-axis and the y-axis, that point's called the origin, and it's at the location 0, 0. So does anybody have any questions about this material? Does this seem kind of like old news?
No.
Okay. Let me look at the chat. Chat's looking good. All right. Moving on. All right, so here's some practice for you guys. Starting from the blue point on the left and moving to the right, I want you guys to tell me, and you can put it in the chat, what are the ordered pairs that describe that blue point?
4, 3. It's -4, 3.
Yeah, that's good. Because you walk to -4 in the x direction, and then you walk up 3 in the y direction. So -4 comma 3 is correct there. Okay. But notice that when you're rushing, you might, just neglect to say the negative. And that's kind of like, again, if we're trying to bomb the correct village and you were to write down or type into Alex because you're rushing, if you were to tell me 4 comma 3, I would be over here. That is 4 comma 3, right? So it's on the opposite side of the map. So we really want to make sure that we're being very precise when we're giving those coordinates, okay? So that being said, I kind of got ahead of myself there, gave away the purple point, but can you guys tell me, hopefully you guys didn't see that, what is the purple point's coordinates? What's the x value or the x coordinate?
0,
And the y coordinate?
negative 3.
Yeah, 0, -3 is correct. Anybody confused about that? I know it's going a little bit fast. Questions, comments? Okay. Can you guys give me the coordinates for this yellowish orange point we have here?
2, 0.
2, comma 0.
2 comma 0 is correct. Okay. Good. So there's going to be some questions when you get into the Alex homework here in a minute that will say, here's a bunch of points. Give me the ordered pairs. You have to remember that the x value comes first. So one thing that some students like to see is that whenever I write down x comma y, maybe to remind yourself which direction goes first. X is left and right, and y is down and up. And so that's one way that you could visually represent that just so that you remember, because there's a lot of information in this material. So I know that sometimes it's easy to get flustered or kind of rush through stuff and make little mistakes. But like I said, we want to bomb the right village, right? Preferably we don't bomb any villages. Maybe we're bombing them with gifts, with humanitarian aid, hopefully. All right. Moving on. Another piece of information or trivia that might help you or might annoy your friends is that mathematicians categorize the Cartesian coordinate system into 4 quadrants. So think about it this way. The PowerPoint slide right now is just a blank page. Once we draw the x-axis and then the y-axis, you have now cut that page or cut that space into 4 sections that we call quadrants, quad meaning 4, right? The way mathematicians traditionally number these quadrants is starting with the upper right quadrant. We call this quadrant 1. In quadrant 1, all of the x values are positive and all of the y values are positive. Okay. Then we move to the left, quadrant 2. And if we move to the left, then the x value is negative. But then if we get into quadrant 2, we have to move up in the y direction. So we have positive y's. Quadrant 3 is moving counterclockwise. Okay. And in quadrant 3, you've gone to the left and then down. So that's the negative x direction, then the negative y direction. And then finally, we have quadrant 4, which is over to the right in the x direction and down in the y direction. Okay. So one way that you can remember this is just start off with quadrant 1 in the upper right corner, and then you're moving counterclockwise through the quadrants, numbering 1, 2, 3, 4. Okay. And the only reason I put this slide in here is because there is maybe 1 or 2 questions in the homework that say, here's an ordered pair. Which quadrant is it in? So like if I just randomly gave you a set of an ordered pair, like I said -5, -8, can you tell me what quadrant that's in?
3.
Yeah, that's in,
3.
Quadrant 3.
yeah, that's in Q3, right? And it didn't really matter if we literally plotted that point, right? The cheap trick is that if I know that both of them are negative, it has to be quadrant 3. Does that make sense?
Yes.
Okay.
Yes.
And again, you'll get some practice in the homework here in a second, so I'm not going to delay that point too much. Okay. But let's put it all together. I said before, like, what is gasoline? What do butterflies have to do with any of this Cartesian coordinate system stuff? Well, typically, whenever we're looking at an x value and a y value, two different variables, we organize them in a table. And as we saw before, if we have an equation, we can figure out if we're given an x value, how do we find the y value, right? We take that x value, sort of like the way we did with some of the problems yesterday when we were evaluating expressions and evaluating functions. We took this x value, we plugged it in for x, and then whatever we solved, right? Whatever we evaluated, that would be our output value, and that's what we're calling the y value. Okay, so this whole class, this whole algebra thing really revolves around understanding that we're going to take some numbers that we're going to call x values, plug them into some equation. Right now, we're going to stay with simple linear equations, and then we're going to get out y values or output values, okay? And we're going to do that over and over and over again, which is why I need you guys to become best friends with your calculators, okay? Because you could do these calculations. They're simple. 25 times 30 is 750. 60 times 25 is 1500, okay? But if you were to do this by hand, it's going to be extremely tedious, and then you're going to start to question what you're doing in life, okay? And we don't want you to get to that place. Nobody should have an existential crisis. So we have those x values, we have those y values, and since we have them, think about this. We actually, like with this first point, we have x equals 10, y equals 250. Well, we can make a graph if we wanted to, because that is 10, comma, 250. And if we had a big enough graph space, then we could plot that, right? You go over to 10 on the x-axis, you go up 250 on the y-axis, and then you plot that point at the intersection of that x value and that y value. Okay? So again, this is just a big overview of what you're going to be seeing in the homework. So if right now it's not really clicking, you're not feeling emotionally attached to this idea, you're going to get the practice, and with the practice, it'll start to like sink in. Okay. Does anybody have any questions before I move on to some other concepts about these graphs? Let me back up a little bit. Okay, no question. Some more definitions for you then. If we're looking at a graph, then sometimes there are special points that we have to pick out and be aware of, right? And those points that are really important for most functions or most graphs are called intercepts, okay? And there's two types of intercepts. You have x-intercepts that are any point that falls on the x-axis, okay? When we start graphing things, whether it's a line graph or whether it's something a little bit more curvy, an x-intercept is just any point that falls on the x-axis or wherever the line touches or intersects the x-axis. Okay, it's literally what the name is, right? It's in the name, it's an x-intercept. Okay, so if I have an x and y axis and I have my coordinate system, I might have a point like so. Can you guys tell me, is this an x-intercept or is this a y-intercept?
An X.
How do you know that?
On the x-axis.
Because it's on the x-axis. Yeah, that's perfectly fine, right? It's not a crazy concept, right? And I'm not asking for some like philosophical discussion of like why it's just that it's on the x-axis. That's it. That's the answer, right? And then similarly, the definition for the y-intercept is any point that falls on the y-axis or anywhere your graph touches the y-axis. So if I had a point like this and I asked you, is this point an x-intercept or a y-intercept? What would you say?
Y-intercept.
And why is it a y-intercept?
Because it's on the y-axis.
Because it's on the y-axis. Okay. Now, turning our attention to that x-intercept, can you guys tell me what the coordinates for that x-intercept are?
3, 0.
3, 0 is correct. Okay. And what are the coordinates for the y-intercept?
-4, 0.
Incorrect. Try again.
0 minus 3.
0,
Incorrect.
-4.
0, -4, right?
Oh,
Right. So there, those first two responses, if you're rushing it, right, this is the kind of thing that it should feel easy. And like, I'm not trying to break anybody down here, but like if you're rushing through it, you're gonna mess up the x and the y value. So remember that the x value needs to come first. So think about it this way. If we start at the origin, right, if we start here, ask yourself, did I have to go left? Did I have to go right? Did I move at all to get to this point down here? Did I move left or right? No, right? So this number on my x-axis is 0. Okay? And then I'm going to change colors because now we can focus on moving up and down, right? And so now from the origin, I can go down 1, 2, 3, 4. And so I have 0 for my x. I have -4 for my y. And just if you're rushing it, even though I know you probably know the correct answer, if you don't type it into Alex correctly, or if you write it down on paper incorrectly, it's going to throw off everything else. So you have to take care because otherwise, if you're not cautious, you're going to create a lot of headaches for yourself. And I'm trying to get you guys to avoid those headaches. Okay. All right. So those are intercepts. There's this other concept that we're going to be playing around with a lot throughout the semester called domain and range. And the basic definition of domain and range is if we have a set of ordered pairs, which if we have a table, we have an x and a y, and they're paired together, right? In this table, we have 10, 250, 3, 750, 60, 1500, right? The domain, by definition, is the set of x values that belong to that ordered pair. Okay, so can you list all of the x values for me? What are the
10,
x values?
30, and 60.
10, 30, and 60. This part here is the domain. I'm just going to put a D so I don't have to write the whole word, but that's the domain. Okay. And the range is the set of all of the y values that belong to that set of ordered pairs. So what are all the y values here?
250, 750, and 1500.
You got it. That is what we're going to call the range. Okay, that's the set of all the y values. Okay. Now, when you're going to be expected to write this down in a particular way. When mathematicians write a set of numbers or a list of numbers, what they do is they enclose those lists in this symbol, which looks like curly braces. So they're called braces. Okay. And so when I write the domain down, I'm going to put D for domain. I'm going to put a colon here. And then I'm just going to list the numbers in the domain, which are 10, 30, 60. And all those numbers are separated by a comma. And that's the domain. So if I ask you for the domain, that's it. That's all you have to write down. Okay. Make sure you use these braces and then list the numbers. Do they have to be in numerical order? Not at all. Okay. Put them in whatever order you want, but just make sure you have all those x values. Does anybody have any questions about domain?
No.
Then the range is going to be similar. We're going to put R colon, like this is if you were writing it down on paper. Then we're going to put these braces here. And then we're just going to list the y values. 250, 750, and 1500. And that's our range. Sorry, that looks like a 6, 0. There we go. Any questions or comments there? Does that seem pretty easy? I'm just going to give it a moment for you guys to sink in. Sink into a depression, a deep depression that you'll never escape. Okay. All right. Things will get a little bit more complicated when we start seeing actual graphs of functions. Okay. So here, pay attention to the curved line that's colored green. Okay. That's going to be the function that we're talking about here, and we're trying to describe all of the values that are spanned by this green line here. Okay. But I'm sure you guys know what I'm like the words that are coming out of my face, but maybe it's not clicking here. So what I want to do for a moment is just switch over to my document camera and draw a little picture so that we can get what is Mr. Aguilar talking about here. So if you guys bear with me, I want to take a moment to think about something. I'm going to draw a number line here. I'm going to start the number line at 0, 1, 2, 3, and go to 4. You guys okay with that?
Yes.
How many numbers? Let's just zoom in. I'm going to zoom in and focus here between 0 and 1. Okay, just that segment of the number line, and I'm kind of zooming in. How many numbers are between 0 and 1?
None.
What do you mean none?
Oh, negative.
No, no, no. So like between 0 and 1, there's some numbers in here. So let me give you a kind of a concrete example here. If I put a line perfectly in between 0 and 1, what number belongs there?
0.5.
0.5.
You guys say 0.5, I like 1 over 2, right? But it's half, right? 0.5, 1 over 2. So how many numbers are between 0 and 1?
A half.
Well, there's one number here, there's 1/2, right? Or 0.5. But what if I cut that in half again? What is half of 0.5? Here, I'll call it 0.5 here just to help y'all out.
Would it be 1/4?
It would be 1
Quarter.
over 4. Or you guys might call it a quarter, right? 0.25 is a quarter. So couldn't I do that again? And you guys might not be strong with fractions, but the next one is 1 over 8.
1/8.
And 1 over 8 is, I think it's 0.125, if I'm not mistaken, 0.125. 0.125. Okay, I'm done with decimals now. But like, I'm asking you, how many numbers live between 0 and 1? And like, we can find more numbers here. The number that goes here is 3/4 or 75 cents, right? We have numbers like 0.99999, right? A bunch of weird stuff. Here somewhere I have like 0.333 repeating forever, which is also equal to 1/3. But what I'm saying is that there's actually an infinite number of decimal numbers here, right? You cannot count how many numbers are there because like if we start at 0, I could say, oh, what about 0.1? And what about 0.01? And what about 0.001? And what about 0.0001? And so on and so forth, right? So in our daily lives, we don't really think about the number line except for usually whole numbers. And then when we're dealing with money, maybe 2 decimal places. But the reality is that between any 2 whole numbers on the number line, there's an infinite number of numbers between any 2 whole numbers, right? We couldn't possibly count how many values are there, okay? So you might be thinking, okay, this is what all does this matter? The thing is, I'm going to draw for you a little graph. Here's my x-axis. Here's my y-axis. I'm going to put -2 here. I'm going to put 3 here, right? I'm going to draw a line that goes from here. We have this point, and it goes all the way and stops here at 3, okay? And this y value, let's just say that this y value is 4, okay? How many x values are between the two endpoints of this graph that I just made? This line here between this closed circle and this open circle. Can I list all of the numbers that are between -2 and 3?
No.
No. There's an infinite number of values. Okay, and so since I cannot list all the x values, I need a new way to write the domain of this line graph. Okay, and so instead of writing the domain as a list of all the numbers between this point and this point, I'm just going to write the endpoints. So this line starts at -2 on the left and then continues on until you get to 3 on the right. And those are my two endpoints. And so if I have a closed circle or a closed point on the left, then I'm going to use a bracket to indicate that I have a closed circle or a closed point. And on this right endpoint at 3, I have an open circle. And since that's an open circle, I'm going to use parentheses to indicate that that's an open point. This is called interval notation. And so we're going to run into a bunch of different graphs where you cannot possibly list all of the x values and all of the y values. And so interval notation is the way that mathematicians communicate to each other. Oh, this line extends from the left from -2 to 3, and the bracket tells me I'm closed on the left and I'm open on the right. And that's how we're going to write the domain of a function that looks like this. Is that weird? Yes. Okay. Because it's probably new and we have to get some practice with it. Okay. Let's turn our attention back to that PowerPoint because that slide had a funkier looking graph that we want to kind of assess. What is its domain? What is its range? So again, we're looking at the green curve and think about this for a moment. How far to the left does the graph go before it stops? What's the x value that's on the farthest left?
-2.
-2, right? This is the leftmost point at -2. And then if you were to trace the graph, maybe with your finger or with a pen, the graph is going to move up. And this is where it gets confusing because the graph is moving up, but I am concerned about how far to the right does it go? Because domain is how far to the left, how far to the right. Okay, so how far to the right is this graph going? Sorry, I kind of got off track there. It keeps going to the right?
Positive infinity.
Yeah, so if that graph is continuing to push to the right as it goes up, then we're going to say that that graph goes all the way to positive infinity. So the domain would be written as -2 on the left, positive infinity on the right. On the left, we have this closed circle, so I'm going to put a bracket here. And infinity is always a parentheses because you cannot capture it. So we say that infinity is open. Are you guys okay with that?
Yes.
Okay. Because this is what starts to get students turned upside down a little bit. Once you have the domain figured out, then we need to look at the graph again, but now we're going to assess it as far as how far down does the graph go? What's the lowest y value it goes down to? And then what is the highest y value it goes up to? So now we're changing directions, right? We're thinking about a different dimension, that's the y dimension. So what's the lowest that the graph goes down? What's the lowest y value that it goes down to? Somebody just put in the chat, Audra, thank you. It is 0 down here, right? This is a y value of 0. And then, you know, in those corny like Lifetime movies where like the kid is growing up and they do a montage and the parents put the kid up against the up against the wall in the kitchen, they measure how tall the kid is getting over the years. Well, how tall is this graph getting as we trace it all the way up? How does it ever stop going up?
It's infinite.
No.
Yeah, this green
Infinite.
graph is going up forever. So it has an infinite height, right? So for the range, you want to change directions to thinking about what is the bottom of the graph and then what is the top of the graph. So we said the bottom, most y value is 0, and that this graph has an infinite height, right? So it's always bottom to top. And then the bottom, because it has a definite stopping place, you're going to put a bracket. And since it never stops at the top, that's open. We put parentheses for infinity. Okay. So I know that's going to take a lot more practice because there's different kinds of graphs that you're going to see. So trust me, you're going to get the practice. It's going to be in the homework, and you might struggle with it a little bit. But does anybody have any questions or comments about domain and range for this graph?
I do. The little circles. What did you say that was again?
Yeah, so the circles, like whether they're open or closed, is that what you're asking?
Yes.
Yeah, so if you have an a closed point here on the left, right? That tells you that you're having a bracket when you write this in interval notation, right? The leftmost x value was -2, so we can bracket that off. But if that had happened to have been an open circle, then we would put a parentheses there for the domain. Okay, so maybe this might help. Let's say parentheses means open, and that's the same thing as an open circle. I mean, that looks like an O, maybe that's hard to read, but bracket means closed or a colored in circle or a big old dot. Okay, and definitely we're gonna get some more practice with that. So maybe write that down in your notes. It'll come back, right? If you have to ask me this later again, I'm not gonna feel bad. It takes a while to sink in. Any other questions, comments? Okay.
No.
Okay, so what I want to do now is just kind of put a bow on this. There's a couple more slides in this presentation, but I'm going to skip them and kind of throw you guys into the deep end here. What you really have to understand is we talked about a lot of stuff, and the concepts seem like they're all over the place, but they're really related to this idea that in this math class, we use algebra to describe things with different symbols and characters, numbers, variables, mathematical operations, right? But now when we start graphing, we're marrying that with geometry so that we can visualize what's the relationship between the x value and the y value. So like throughout this 8-week course, we're going to be introduced to a new kind of function, and then we're going to graph those functions. So you're not going to be able to get out of understanding, how do I find the x-intercept? How do I find the y-intercept? Can I describe the domain and the range of this function? We're going to get a ton of practice with that over and over. Right now in this first unit, we're going to be introduced eventually to a bunch of other functions. But in unit 2, we're going to focus on quadratic functions. But we're going to be doing a lot of the same things like find the x-intercept, find the y-intercept, tell me what the domain and range are. When we get to unit 3 and 4, we're going to learn about different kinds of functions, and it's going to be the same questions. How do I find the x-intercept? How do I find the y-intercept? What's the domain? What's the range? And then answer a bunch of other questions that are related to that, okay? So for about the next 30 minutes or so. Okay. What I'm going to do, let me go ahead and stop the share, is I'm going to, in Zoom, put you guys into breakout rooms. Okay. So that's basically my way of grouping you together. And I'm going to give you guys 30 minutes to work on your first homework assignment, which is, let me see, I can't find my, there it is, which is rectangular coordinate systems and graphs. Okay, so I'm going to probably put you guys into groups of 5, see how that works out. If you need help in those breakout rooms, there should be a button at the bottom that says ask for help. If you hit that button, I will pop into the room and help you out with whatever problems you're working on. But the reason why I'm putting you into these groups is that so that you can communicate with your group members. And if you're stuck on a problem or have questions, you should be able to ask your classmates, okay? Kind of simulate what it would be like if we were doing group work in class. If you've already done homework number 2 because you got ahead, well, then I please just ask that you help out, answer any questions, or clear up any misconceptions or confusion that your classmates might have. Okay? Does that make sense? Okay. Where am I? Here I am. Where's Zoom? There we go. All right. So what we're gonna do right now is look at that worksheet that I built to do a crash course in solving linear equations, graphing linear equations, and I'm going to give you those strategies so that you will be able to then turn around and hopefully tackle the next homework assignment on your own, which is going to be assignment number 3, linear equations, inequalities, and intervals. Okay, so let me go ahead and share my screen so we can just take a look at that worksheet, and then I'll switch us over to my document camera since I also neglected to print out a copy of this worksheet for me, so we'll have to do it on pencil and paper. Here we go. Let me drag this over here. Can you guys see this screen?
Yes, sir.
Okay. All right, and I'll blow this up a bit. So the first set of problems here are just, it says linear equations, okay? And this is designed to give you a crash course on solving linear equations. So I'm going to start off by first writing down the problem. The first one says 9x minus 6 equals negative 3x plus 30, okay? And now I'll switch over to my document camera because I like disorienting you guys with different screens. So here we go. Boom, there you go. Can you guys see that okay? Okay, maybe that's a little bit better. All right. So the idea of solving an equation is that we're solving for the missing value. In this case, mathematicians' favorite variable is x. So you can see that this equation has this equal sign here, and it has an algebraic expression on the left, an algebraic expression on the right. So I like to think of an equation as being made of at least 2 parts. We have the left-hand side, we have the right-hand side. Okay. Sometimes students like to put a little dashed line through the equal sign to help them distinguish the 2 sides. But these are just like visual teaching aids. At some point, I'll drop these teaching aids and just solve the equation once we get used to this, okay? But the idea is, for most purposes, we want to move any variable term over to the left-hand side of the equation, and we want to move any constant terms over to the right-hand side of the equation, okay? But to be honest, it doesn't matter where you move things. You just need to move your variables to the same side and your constants to the same side, okay? There's a number of different ways to solve this, but I'm going to try to be consistent, move my variables to the left, move my constants to the right. That being said, if I want to, for instance, move this negative 6 over to the right-hand side, I can't simply pick it up and copy it over here, okay? I have to cancel out this negative 6. So you have to ask yourself, what's the opposite of minus 6?
Adding 6.
Adding 6. Okay. So if I do something to one side of the equal sign, I have to do it to the other side to maintain balance. So if I add 6 here, I have to add 6 over here. And I'm putting it underneath the 30 because these are like terms. Okay, so I want to keep my like terms together. Negative 6 plus 6 is 0. So usually we're really lazy as mathematicians and we just say this cancels out. But now we're going to say, okay, let's just bring down 9x because we still have that left over equals negative 3x. And then 30 plus 6, we can simplify that to positive 36. Are you guys okay with this?
Yes.
And if this is like excruciatingly slow, we will pick up speed at some point. So just bear with me while we do this. Okay. Now, we next have to move the variable over to the left-hand side. So my first step is always move the constant to the right. Okay, that means my second step is going to be move variable terms to the left. Okay, but again, I can't just pick this up and drop it over here as a negative 3x. I need to say, what's the opposite of subtracting 3x?
Adding.
Plus
Adding
3.
3x. So I'll add 3x here, and to maintain that balance, I have to do it to the other side. And so I can draw a line here and say to myself, well, I'm pretty lazy as a mathematician. Negative 3x plus 3x, that's 0. So I can cancel those out. That means what I'm going to be left with, 9x plus 3x. Can you guys tell me what that's going to simplify to?
12x.
We have 12x is equal to 36. Any questions up to this point? Okay. Can you guys tell me what the last step is to getting the variable isolated?
Dividing
by
by
12.
Yeah, you always want to divide by this coefficient. And so the reason why you're dividing by 12 here is because think about what the coefficient means. And this is just a recap based on what we talked about yesterday. The coefficient 12 is technically being multiplied by x, 12 times x. So the opposite of multiplying is dividing. So to cancel that out, we're dividing by 12 on both sides. 12 divided by 12 is 1. So we can say we have 1x left over or simply x left over. Those cancel out. So we have x is equal to, do you guys know what 36 divided by 12 is?
3.
3.
Yeah, and if you weren't sure, you can just pop that in the calculator as well. You get 3. And now, do we have x isolated?
Yes.
Yeah, we have x on the left-hand side. We have a number on the right-hand side. So this is telling us the missing value x is equal to 3. And we have finished and completed this game. And that's it. That's our solution. Okay.
I have a question.
Yeah, what's up?
So, is it, I got the same answer as you did, but I did it different. I did the variables first. Is
That's
that
fine.
wrong?
No, that's not wrong. You got the same answer, right?
Yeah.
Right. And that's why I said like there's a million and one ways to solve this equation. Some are
Okay.
more complicated than others. I am just going to be consistent and try to move the constant first, then the variable last. But if you want to do it the other way, where you start with the variable, if I started with the variable, I would still add the 3x to the 9x, right? So you still got the 12x. And then eventually you still would have added that 6 over to the other side. So like it still shakes out the same.
Okay, good.
Yeah. Any other questions or comments? Okay. So rather than switching you guys back and forth between the worksheet and the document camera, I'll just go ahead and write down the next problem here. Okay. So let's do it on the back of this so it's a nice blank page. We have 1/3 x minus 3/4 x is equal to 1/12. Were you guys super intimidated when you saw this?
You'd have to.
Yes.
Okay. Now, even though I tell students like you can use the calculator to simplify the fraction stuff, for some reason they don't believe me, and they in my morning class, students were like, "Well, don't I have to multiply by 3, or don't I have to get a common denominator before I do stuff?" And I would say, no, let the calculator do it for you. Okay? So I'm gonna rely on this calculator and show you guys something here. First, if we look at this equation, I can break it up into the left-hand side and the right-hand side. The right-hand side is a lot smaller than the left-hand side here. Okay. But on the left-hand side, can I simplify this? Can I combine like terms?
Yes.
In theory, I can, right? Like we might be a little bit afraid about the fractions, but this is an x term, this is an x term, have the same variable and same exponent. So I should be able to combine those like terms. So what you want to do is at any point in an equation, if you can combine like terms, go ahead and do that. So let's combine like terms. And with the calculator, this is going to be super fun. In the calculator, what we want to do is 1/3 minus 3/4. Are you okay with that?
Yes.
Because like we know that this is going to become something x, right? But we need to do 1/3 minus 3/4. In your calculator, I want you guys, if you have a calculator like this, and if you haven't yet picked one up, I highly urge it. You're going to press alpha, the green button. So I'm going to write down alpha. Then you're going to press this y equals button here because it'll give you the F1 options. So we're going to put y equals, and then we're going to hit enter. Okay, alpha y equals, sorry, I messed that up. Second quit. Alpha y equals enter. And now I have something that looks like a fraction that I can type in, right? So now I'm just going to type in 1, use the arrow pad to go down, and put 3 in my denominator. And I have 1/3, right? And I just need to do 1/3 minus 3/4. So I'm going to put subtract, and then I'm going to do this sequence of buttons again. Alpha y equals, hit enter to get that fraction. 3/4, and then just hit enter, and the calculator does the work for you. So 1/3 x minus 3/4 x is -5/12x. Questions, comments? Does that seem crazy?
No, that was actually quite simple.
Right. Yeah. I mean, guys, if you really wanted to see it done by hand, you would have to multiply this fraction by 4/4, multiply this fraction by 3/3, so that you get a common denominator. This becomes 4/12 minus this becomes 9/12. Then that's how we get the -5/12. But like, we don't have time for that. Eventually, we're going to get to harder stuff later on. So I want you to make the calculator your best friend and let it do this quote unquote easy stuff, because we're going to have bigger fish to fry later. Okay? Lean on that calculator so that we don't have to waste our time with this garbage. Okay? So then we're back to the equation. We have -5/12x equals, and then we didn't do anything with the 1/12 here. Okay? Pretend for a moment that this was just a whole number, right? Something times x. What would I usually do at this step? to get rid of that whole number?
Divide.
Divide. So guess what I'm going to do here? It doesn't matter whether it's a whole number or a fraction.
You're gonna
I'm going to
multiply.
divide this by -5/12 and divide this by -5/12. Okay? Anything divided by itself is +1, so that cancels out, and I'm left with x is equal to something. But even though you might be rusty on dividing fractions by hand, we don't need to do this by hand. Okay? So I'm going to clear my calculator. I'm going to do 1/12 divided by -5/12. And then let the calculator do the work. We get -1/5. So that is now -1/5. And did I get my variable by itself?
Yes.
Sure. X equals -1/5. That is the answer. Okay. Does anybody have any questions, comments, concerns there? Do you guys see how easy it can be if you let the calculator do some of the fraction stuff for you?
Yes.
That was amazing. Thank you.
Okay. Yeah. So learn this sequence of buttons in the calculator, and as you know, we approach other kinds of problems, I'll show you some other neat tips and tricks that you can do in the calculator. But for now, that fraction, those fraction options are going to be really helpful. So sometimes students do like -1/5 as a division problem, and then they get this decimal. But for some decimals, like if we had 1 divided by 3 or 1/3, a lot of times students will accidentally just cut this off and say, oh, it's 0.3 or it's 0.33. Once you cut that off, you've changed the value. It's no longer precise. We want to make sure that our answers are always simplified fractions. Okay. But if you have a decimal like this, there is an option here. If you go to alpha y equals, this fourth option down here says F convert to D and D convert to F. That converts between fractions and decimals. So if we went down to this fourth option here, we could convert our answer back to a decimal or back to a fraction if we wanted to. Okay, so that's another useful trick. Practice that on your own time, but really just getting these fractions is going to be super helpful. Okay. All right, are you guys ready to move on to the next one?
Yes.
All right. Let's do a new piece of paper. The third one says 2 times x plus 4 is equal to -3 times x plus 5. Okay. And I'm going to stop writing the left-hand side, right-hand side, but I will put this little dashed line so that we can see the two sides of the equation. Sorry, you can see that better now, right? Okay. First step is always to simplify both sides of the equation separately. Okay. So if I want to simplify this, I can use the distributive property. And if I distribute the 2, what should I get when I'm done simplifying this?
X plus 4?
Uh,
2x plus 8.
2x plus 8. Yeah, so be careful there because sometimes students will multiply the first term, but then they'll just bring the 4 down, or they'll bring that second number down because they forgot to multiply. Okay, so just make sure you distribute that out completely. And then we'll do the same with the -3 over here. So we should have -3x minus, because it's a negative times a positive, minus 15. Questions about that? So step 1 was to simplify. Okay. Now, if you're comfortable solving it from this point onward, then you can go your own way, as Fleetwood Mac would say. But what I like to do is move the constants first. So the first thing I'm going to do is subtract 8 subtract 8. 8 cancels out. I have 2x is equal to negative 3x, and then negative 15 minus 8. If subtracting negative numbers or two negatives is confusing to you, just use a calculator. But this should be negative 23, I think.
Yes.
Okay. So if we get that correct, then we should move this negative 3x over to the other side, which involves adding 3x over to this side so that these guys cancel out. 2 plus 3 is going to be a 5x, and now that's equal to negative 23. Okay. Is that okay with you guys? What's the final step here?
Divide by 5 on both sides.
Divide by 5 on both sides. So we have x isolated, and we can keep this as a fraction. Actually, if you think to yourself, oh, 23 seems kind of big, maybe that can be simplified or reduced. Guess what? You can check in the calculator by doing alpha y equals again, hit enter. And if we put in negative 23 over 5 in the calculator and hit enter, if it remains unchanged, then that means that's a fully simplified fraction. That's your final answer. Okay. So we didn't have to do anything there. The number didn't change. It stayed negative 23 over 5. I mean, if you really want to get a sense of what this number is, as though it matters, you could put negative 23 divided by 5 into your calculator, and it's negative 4.6. But I really want you guys to wean yourselves off of relying on decimals there. Okay. So our steps were to simplify, and then we moved our constants. Then I moved my variable terms. And then the last step is always to divide the coefficient. Okay. Okay, in the interest of time, there are a couple of graphing problems here. But I'm gonna skip those because I think it's really important to get to the solving linear inequalities because that's what the next homework is all about. So I want to show you how to solve two of those, and I'll let you guys do the rest of the problems that we haven't gotten to on your own. Okay. So scroll down or look at the linear inequalities problem. We'll do the first one and the last one. Okay. So the first one here says to solve 3x plus 7 is less than 16. Okay. It says to solve this linear inequality and then draw a graph of the solution and then write the solution in interval notation. Okay. So the first thing I need to ask you guys is how many variables are in this equation?
One.
Just one variable, right? We have one variable, which is the x variable, right? So when I say graph, we don't have a y-axis here. We just care about our x value. All right, so that's one thing that we'll see here in a second. But let's go ahead and jump in and solve this. An inequality is just like an equation, except you have this weird looking symbol here. And whether you call this less than or greater than, it doesn't really matter until we finish solving. So we'll interpret it later. I'm just going to draw a dashed line here, and then we'll solve it the same way we solve linear equations. So if I want to cancel out this 7, what do I need to do?
Subtract.
Subtract 7 from both sides. The 7's here cancel out, and I'll get 3x is less than 16 minus 7 is going to be 9. Okay. And then the final step, just like solving a linear equation, just divide by 3. The 3's cancel out. I now have x is less than 9 divided by 3 is 3. So this is your solution as an inequality. Okay. And the way that you can sort of remember what these inequalities are saying is by remembering the phrase, the alligator eats the bigger number, right? So if you think about this as an alligator mouth, the way you would read this to yourself is x is less than 3, right? That's how I would say that. Because the alligator is pointing its mouth towards the 3, so the 3 is bigger. So x is less than. Does that make sense? Okay.
Yes.
Might seem childish, but it will help you in a pinch. I swear to you. All right. Then to graph this, like I said, this solution just has an x value. So I'm just going to draw a number line, or you could think of it like the x-axis. And my number line extends from negative infinity to positive infinity. Based on this solution, all I really care about is x. Or I'm sorry, all I really care about is focusing on this number 3. So I'm going to put 3 right smack dab in the middle of this number line. Okay? And if I had a highlighter on me, I would highlight the region of the number line that's indicated by this inequality. So think about it this way. X lives either to the left or to the right of this number 3, but it depends on what this inequality says. So if x is less than 3, which side of 3 does x live on? The left side or the right side?
The left.
The left side, because the numbers on the left of 3 are less than 3. So what I'm going to do is, if I had a highlighter, I would just highlight this whole area over here, everything to the left of 3. Okay? But this doesn't say that x can be equal to 3. And since x cannot be equal to 3, I'm going to put a parentheses here because this is an open inequality or an open endpoint. You can either put a parentheses, or if you prefer, you could put an open circle, but it means the same thing. Okay, so that's what your graph would look like. If I had a highlighter, I would have put it directly on the number line and highlighted this stuff and put the parentheses here. But because I didn't want it to overlap and be confusing, I just sort of raised it up a little bit off the number line so you could see what I'm highlighting, quote unquote. Okay. All right, so that's what the graph looks like. Interval notation, and we saw it with domain and range earlier. Interval notation looks just like this graph that we drew. Remember, we want to think about what is the leftmost side of this highlighted region and what is the rightmost side of this highlighted region. Okay? So if I'm looking at what I highlighted in red here, how far to the left do I go on the number line?
Negative
It keeps
infinity.
It keeps going. So we're going to say it's negative infinity. That's the left. All the way to, how far to the right do I go before I stop?
3.
3.
3. That's the right end of this graph, right? So I have my left, I have my right, and since this is open over here on the 3, I'm going to put a parentheses there. And infinity, whether it's negative infinity or positive infinity, we can never close it or we can never capture it. So that's always going to be a parenthesis. So infinities are always open. Okay, and then that's how we're going to write our interval notation. So whether we're talking about the inequality or the graph or the interval notation, all these 3 things are different ways of representing that same idea that x is less than the number 3. Okay, now technically I've run out of time. It's 8:40. So if you guys have to go, you can go. But I do want to ask you guys, do you want me to do another one of these?
I do.
Yes, please.
Okay, so
Yeah,
if you'll bear with me and hang on, if you gotta go and drop out of the Zoom session, I totally understand. This is gonna be recorded, right? I am currently recording, but let's do that last problem so that we can get another freebie, and that's one less homework problem that we have to do, right? Okay. So let's look at the third problem for these inequalities, which is 3 minus 5 times x minus 1 is less than or equal to 28. Let me know when you guys are ready.
Let's go.
All right. The battle cry of my generation, millennials, is LF. What is it? LFG? Let's do it. Okay. So I'm going to put my little dash line here just so that we can see where that inequality is. And then we want to simplify this because whenever we have parentheses and we can distribute, we want to go ahead and distribute that. But be very careful here. This is a -5 that we're distributing. So we want to distribute that -5 and multiply it by x. So I should get -5x here. Okay. I'm also going to take -5 times -1. That should become a +5 now because a negative times a negative is positive. And then I'm just going to bring everything else down. So I haven't used this 3 yet. I'm going to bring down the inequality symbol. I'm going to bring down the 28. On the left side of my inequality, can I combine like terms?
Yes, the 3 and the 5.
The 3 and the 5 become an 8. So it doesn't matter what order you put that in. I like to just put that in the back. So it's going to be -5x. That comes down. And then these guys become a +8. Okay. If you put 8 minus 5x, that's perfectly fine too. It's not going to make a difference. Less than or equal to 28. And now we're just solving this the same way we would an equation. So how do I cancel out that +8?
Subtract 8.
Subtract that 8 from both sides. That becomes now we drop the -5x. That's less than or equal to, and this is 20. Okay. Now what's the last step here?
Divide from -5.
Okay, I'm going to divide by -5. Okay, and this is where we want to stop because there's something very important that's different here from solving equations. And that is you made the decision to divide by this -5 here. Divide by a negative.
Oh,
And this doesn't happen with equations, but with inequalities,
it's a
if
flip
you
of
divide by a negative, you have to now flip this
That's right.
so that the inequality faces the opposite direction. Anytime you divide or multiply an inequality by a negative, it flips the direction of that inequality. So flip the inequality. When you divide or multiply by a negative. But everything proceeds the same way. So like -5 divided by -5, that cancels out. And so we still have x. And then 20 divided by -5 should still be -4. So nothing has changed here except for the flipping the inequality symbol. The process is pretty much the same as solving an equation. And if you forget to flip that inequality when you divide by a negative, it's going to hurt. Like it's just going to be frustrating, okay? But this is our solution as an inequality. Now we should be able to graph it, and we should be able to write that in interval notation, okay? Does anybody have any questions before I move on to the next steps?
No.
No.
Okay, so we'll do the graph first. Here's my number line. I always say put negative infinity, put positive infinity, and then we're focused on this number here. So I'm going to put -4 in the middle. If you need to, because I have some students that I thought they were getting it, but then they kept messing up this problem in the homework, and I kept having to sit there and kind of coach them through it. Translate this into plain English for yourself, right? How would I read this? I would say X, the alligator is eating the X, so X is greater than. And then if I have the equal bar here, that's greater than or equal to -4. Okay. So once we've translated that into plain English, we can ask ourselves, well, if does X live on the left side of -4 or does it live on the right side of -4 based on it being greater than -4?
Right.
It has to be on the right side, so I'm going to highlight the right side of this graph because that's where X lives. Okay. And because I have this equal sign, that means that X could be equal to -4, which means that this endpoint on -4 is a bracket because this is closed.
Hmm.
So closed means that -4 is included as a possible solution. Okay, any questions there? All right. Interval notation, if you have the graph, interval notation should be just a straightforward translation from the graph. Because if you look at the number line, what number for this red highlighted part, what number do we stop at on the left?
-4.
Boom. -4 is the left side. How far to the right do we go?
Infinity.
Boom. Infinity is the right side. Do I have a bracket on the left side?
Yes.
Yep. And infinity is always a parentheses, so I'm going to put that because infinity is always open. That's my interval notation. Okay, so I'm sorry for going over 8 minutes there, but I do want to let you guys know that just to reiterate, if you're not able to get this worksheet done by next class and you still have questions about it, something that's giving you trouble, I would not upload it until you are ready to upload it, until you are confident that you are going to get a decent score on it. So if you need to pop into Zoom with one of the tutors in Math World tomorrow to have them check some of your work, you can definitely do that. And even if class comes around and you have questions, bring them up at the beginning of class and I'll see if we have some time to work through a problem. Because I'd rather you turn in the correct work as opposed to you just kind of half-assing it, but then also teaching yourself bad habits, right? So I don't want you to think oh, I have to turn it in because it's due already. I want you to turn it in when you're comfortable with the material and when it's correct. Okay? So if you have any questions, like I've been saying, I don't want you guys to have an anxiety attack. If anything comes up and you're confused or have any questions, please shoot me a message in Canvas. And I guarantee you that if you have an issue, it can wait until next class. So bring those concerns to my attention and I'll try to address it, okay?
Okay.
All right. So you guys have a blessed evening and I will see you guys tomorrow.
Thank you.
Thank you, you too.
Take it easy.
Buster.